Hello, and good morning. I got a couple of props here I'm going to use in the course of my talk this morning. But real quick, I'm the CEO of PTC. PTC is a fairly large software company based in the Boston area here, out in Needham, to be precise. And we've been doing a lot in IoT and AR, and I wanted to share some of that with you because I think it's pretty exciting, and a lot of it's real. You know, we're engaged with about 1,000 companies right now on the intersection, industrial, B2B customers, at the intersection of IoT and AR. And really my thesis here is that the more you talk about IoT, the more you're kind of magnetically drawn towards AR. And I'll try to explain why I think that happens. But I think that AR is going to be a critical enabler for us to get the full value out of IoT. So you might be thinking, PTC, isn't that an old CAD company? And I'd say, yeah, in the same way that MIT is an old university. But even old universities work on new ideas. And at PTC, an important event happened about 7 years ago, which is the board of directors decided that the new CEO should be a technologist, and they selected me, the CTO, to become the new CEO of PTC. And sort of with that mandate to, let's say, speed it up a little bit or add some more action to the company, we went out and did a lot of crazy things, and I just want to explain them. A big milestone happened last summer when we adopted this new logo to describe our company, what we're trying to do, and it's a P for physical on top of a D for digital. And it's really built on this yin-yang concept. So yin-yang, if you know it, is an Asian concept of two opposing forces that actually add quite a bit of value to each other and create some greater whole, night and day, hot and cold, male and female, that kind of thing. So if you look at PTC, we started as a CAD and PLM and ALM company, helping customers to design products in the digital world to create high-fidelity digital prototypes because it's too darn hard to iterate in the physical world. If you build a physical prototype and change your mind, that's a problem. Big, expensive, long process to change that physical prototype and so forth. So we can iterate for a long time, get it just perfect, and then when we're ready, we're going to cross the boundary. We could do that with 3D printing. Of course, that's a technology that's getting a second wave of interest right now as people go from printing throwaway prototypes to printing production parts that go right onto the manufactured product. But more typically, you'd be doing this in a factory, a subtractive type of process where you're machining things down or injecting plastic into molds or what have you. And more IoT and AR are playing a role in what factories do, and I'll probably touch on that a little bit later in the talk. But that's a second way to get from a digital idea to a physical product. Now at PTC, we always wished that we knew what was going on with the product after it left the factory, because then we could more properly do product lifecycle management. It's a little hard to do lifecycle management for something you haven't seen in years or possibly even in decades. And that's ultimately what led us to make a series of acquisitions and investments around a brand we call ThingWorx so that we could get data back from the physical world and integrate it with our understanding of those same things from the digital world to create this concept we call a digital twin. So a digital twin would be like the avatar for something physical or the proxy. So by consulting this digital twin, you can see how the product's used and problem it's having and so forth, and ultimately use that to improve the design. We also got into service software some years ago, thinking that all this engineering data was important for service. Well, it turns out nothing's more important for service than an understanding of the condition and the status and the use of some asset out in the field. So of course, IoT and analytics and the digital twin helps us think about how to optimize a service process to make it proactive, preventative, efficient, what have you. Now, what led us into AR was an understanding that many times you do have to go into the field and you have this rich information in your digital twin. Sure would be great if there were a way to bring that into the field and put it in the context of the physical product that you're trying to repair or optimize or what have you. And we also saw that virtual reality gives you a way to do that too, but with a virtualized replacement of the physical product, but still get the benefit of all the in-context processing of this information. So this is sort of what PTC is doing right now. You can see we've come a long way from CAD, but everything we're doing still kind of seems to make sense together. And just for fun, I wanted to show you my first little demo here to try to prove out that concept I just showed you. And I'm going to run a piece of software that we call a Thing browser. This is our ThingWorks Thing browser. And before I go any farther, let me say that this thing I have in my hand is actually a hydraulic pump from a Bobcat skid steer. It turns engine power into hydraulic pressure so that you can operate the bucket and so forth on a skid steer. Because what you see if you compare that screenshot to the pump I have in my hand is that it's a mixed mode assembly. It's part physical, it's part digital. And then what I can't show you is that the buttons along the bottom, which would be voice commands on the HoloLens, allow you to do things like, say, disassemble it, and it comes apart. Show me the sensors, and there's a series of sensor readings on there. Show me the internals, and it turns out that because this pump, because it's 3D printed, it wouldn't be this way in the real world, but because it's 3D printed, it has a lattice structure inside. It's not solid. So we'd be able to see the X-ray vision of the lattice structure and so forth. So I'll save that because it's not that interesting without the demo. All right, so what's happened over the last couple of years with me personally, in addition to working on all that stuff at PTC, I've engaged in a couple of research projects with Professor Porter from Harvard around IoT. And that's led to 2 papers which we published in the last couple of years. And another one that's underway, and this third one really is about AR and its influence on IoT in business. And I think you'll enjoy it when it's done. It's kind of in the final editing mode right now. But basically, the story starts out with the idea that more and more things in the world, even this tennis racket, are becoming smart and connected. And so this tennis racket has sensors in the handle, an accelerometer, and an electronic gyroscope. It gathers data from those sensors, uses Bluetooth over to your phone up to the cloud. In the cloud, there's a database of sorts gathering together all the tennis rackets around the world. We're running analytics on them to figure out how your game is evolving, but also how your game compares to everybody else's game. And then we're delivering that back to the end user in traditional mobile applications. So this is a big idea. It's being applied even to tennis rackets. It creates tremendous amount of value because now we can monitor what's going on, even remotely, for things that we used to have no idea. We can, in some cases, have a control loop and be able to change or give feedback to that thing. You could imagine that tennis racket at a minimum buzzing. It's a little hard to control the tennis racket, but same way your phone has a buzz for an incoming call and a different buzz for an incoming text, we could remind you of certain things in your game even while you're playing. But with assets in general, let's say industrial assets, we can do dramatic things to optimize their use and their availability. And then we might even think about giving them the ability to make their own decisions and become autonomous and start optimizing themselves. So when products go from being not connected to being connected, you know, amazing things happen. But one of the things I've observed is that there's something missing, and that is while the tennis racket is part physical and part digital, I don't actually see it that way. Because when I look at it here, I see only the physical tennis racket. And when I look at it here, I see digital information about the tennis racket, but not in the context of the tennis racket. And it seems sensible that I would want to do this and see the two together. And to say, why can't you show me what's happening with that object in the context of that object by taking all the data you got from the sensors and putting it back in the context of the actual object? So in order to do that, we would just park a second stack of technology alongside that first stack. And that's really why I showed you the first stack, was to point out that we humans like to communicate with 2 channels, sound and vision. And it's actually very important. You know, that's why it's not that interesting to listen to somebody you can't see, and it's not that interesting to see somebody you can't hear. It's very interesting to get both of these channels because they bring in something separate. They have different capabilities, but they're also used to quality check each other. You know, if I say, you're my best friend, you're thinking, I don't think so. There's something about what I see that doesn't match you know, what you say. So it's a powerful idea, but now we can put that idea on the physical world. We can gather data through IoT and sensors and analytics, and using computer vision, see that object, recognize it, map all the data we gathered through IoT and analytics onto it, and then show it back to you in the context of the object. So I think it's a big, powerful idea to put those two together and to allow humans to have the data and visual link with the physical world that we love to have with each other to sort of optimize the full communication back and forth. Now, to be clear, I'm not really talking about tennis rackets here. I'm talking about everything in the physical world. It's worth noting that you have the same problem in your car. You know, when you're looking through the windscreen, you don't benefit from the digital information. And when you look down at the dashboard at your navigation system, you now have a set of information that's very important to you. But number one, you first have to understand it, because it's not in context. Is that Green Road, is that I-90, or is that Memorial Drive? Which one is it? You have to understand the scale. Then you have to remember it, and then turn around and map it onto the physical world ahead of you so you know which road to turn on in order to get here this morning. And I was just going through this process as I drove in from the suburbs this morning. It's a difficult process in traffic and so forth. And wouldn't it be great if we could merge these ideas together and produce what you'd call a heads-up display? And of course, we can. We all know what heads-up displays are. It's just today is very costly and specialized to have something with a heads-up display. But to the extent that glasses or eyewear, or maybe in a lot of cases mobile devices, can integrate what I see with the data I need to know and act on, I suddenly have a heads-up display on everything. And that's a big, powerful idea. It also solves another problem, which is the way we're headed today. Everything thinks it's going to get to have its own apps. And I don't think that's really practical. I mean, I don't know about you, but if everything I interact with follows the lead of my swimming pool and my solar system and my smart home, I'm going to be swimming in apps. And when I want to interact with something, the first thing I'm going to have to do is flip through 100 pages of apps to find which app is it that interacts with this thing. And I think this idea of augmented reality gives us a different approach, which is the ability to just figure out what you need to know and deliver it to you. So that's kind of the big idea that we're working on, which is if you start at the 1 o'clock position here, we want to connect to the physical world, both to sensors, but also to automation and control systems, because there's a lot of systems out there that already know things at the edge. We want to draw this data in from the edge and apply analytics to it. Analytics could be big data analytics, could be engineering simulation codes, could be business rules, what have you. But we want to say, what is that data telling us that we need to know in this context? And the context is, who am I? What role am I performing right now as it relates to this physical world in front of me? What do I need as this person performing this role to know, and in what order of priority? And then what I want to do is decorate the physical world with what you need to know, maybe giving some level of priority indication. Throw everything else away because you don't need to know it, and allow you to just simply engage that world with these two channels and see that decorated world that, you know, is the physical world with the heads-up display kind of worn on my head. So I think this is a big idea, how IoT and AR work together. Like I said, we have about 1,000 B2B customers just in the last 2.5 quarters who have used our software to go prototype this kind of concept. There's a huge amount of interest out there. Again, our role at PTC is software. We're trying to provide the software infrastructure and plumbing to make all this happen, and of course work with phones, tablets, eyewear from whomever, you know, makes the best. I want to show you a couple of ideas how this works, actual real customer examples. This service scenario is from a customer of ours called Sysmex. Sysmex makes blood and urine analyzers that you'd see in a hospital. So what's trying to happen here is that the blood technician, not the service technician, the blood technician, gets an alert from the machine that says, I have a clog, what's called an RBC clog. I don't know, that's probably consumable flow is being clogged. And he gets that on his industrialized iPad, actually. And so through IoT, he's getting feedback from the machine, and he presses a button that says, run the cleaning cycle. And so the self-cleaning cycle runs, and it completes and it says, sorry, I was unable to clear the clog. We're going to have to revert to a manual procedure. Now, at this point, I need to call a service technician, or I need to be coached through the process. So what we would show you here is how AR, and hopefully some of my other colleagues throughout the day here, will be able to show you how AR would coach this blood technician through a modest disassembly, pipe cleaner type cleaning process of an orifice, reassemble the thing, run the self-check, and there you are back online again. With the idea that if this machine can't be fixed right now, first of all, it's going to cost a lot of money to have a service technician come. Secondarily, it may be down for a day or two or three. And at the clinic, we got a whole list of appointments that are kind of expecting this machine to run. So it's very expensive and inconvenient and even brand damaging to have this machine out of commission. But AR, coupled with IoT, can get to the basis of what is the problem, what would you need to do to fix the problem, and then let me actually visually coach you through the sequence of doing the things you need to do. Okay, let's try a manufacturing scenario, and this is a manufacturing training scenario. So you see there's a cylinder sitting on a plate, and there's some markers on there to help the camera know exactly where it is. And what you can't quite see, or you can barely see, a red tip device, which is the welding rod holder. I don't know what you call that thing. So this red-handled device would be the welding rod, and we're using sensors to detect where is it, how much pressure is being applied, and at what speed and in what direction is it being moved, and then simulating what sort of weld that would generate, and then augmenting that weld onto the work material. And the idea here is it's very safe welding. It doesn't burn through consumable rods. It doesn't burn through consumable fixtures and parts. It's just a great way to sort of visually understand what you would see if you were actually doing that welding. And then a third example, which has less IoT in it, if we can flip to it, is sort of in the engineering world. So here's a case where we've taken a steel chassis, and we're going to grab CAD data off the screen and augment it into the right place on the steel chassis. And then again, this one was done probably on a tablet. We're walking around the chassis. We might even say, give me a different design variant. There we go. That's a different design. So we're taking CAD data and augmenting it onto a physical assembly to produce a new assembly that's part physical, part digital, to allow us to iterate and say, do we like that? Is that the one you want before I commit the factory to building it? Okay, so what I tried to show you there, if we jump ahead, was some examples in service, in factory, in engineering that use these ideas together. I want to talk a little bit about my theory of why it's important. Data, for example, from IDC says that the amount of data available to mankind is growing, as you know, at an enormous rate. And of course, IoT is a massive new source of data. So we have more data than ever that we want to be able to share, with humanity. But we have a bit of a problem, which is the pipe into humanity is very small. And in fact, if you were to look at this phone there, that's the user interface for my swimming pool. And it's just text, that you have to look at, read, and really all you get is the green indicator of the buttons on or off. But I would argue, I do argue, that we can only consume that type of user interface at 3 words per second. And I say that by saying we measure time, actually, by saying 1001. That's 1 second, 3 words. And very few people can speak faster than that, not much faster. And very few people can read dramatically faster than they can speak. And you can kind of prove that by handing somebody a paragraph and say, read it out loud. So I think your ability to read and visually process the symbology of text is somewhere around 3 words per minute. Okay, now this is the first part of Heppelmann's theorem. The second part is I remember being taught a long time ago that a picture's worth 1,000 words. And we can study that. I don't know if it's worth 1,000 or 900 or 1,100, but there is a huge amount of rich information you can get in 1 second graphically. For example, if you closed your eyes, opened them for 1 second, looked around, and closed them again, if you could remember everything you saw, it would take far more than 1,000 words to describe it in text or to say it verbally. So I'm going to just take for granted that a picture's worth 1,000 words. And then I'm going to take for granted that I can throw 60 pictures a second at you, and you pretty much process all of them. Notice all the little subtle differences and so forth. And you do that every time you're watching TV or sitting in front of your computer or anything else that runs at 60 hertz. So 60 hertz is, as you know, 60 pictures per second. So now I'm saying I actually could do 1,000 words times 60. Now, not completely, because if everything changed in those pictures, you'd have a harder time processing them. But if I could now not try to funnel it through a tiny little window in front of you, but actually make it part of your peripheral vision, because we see so much more than we have immediately in front of us, and we process it so fast using peripheral system one type of processing, I think that would gross it up by 100. And I say that only because I could imagine 5 more of them this way, 5 more of them that way, 5 more that way, 5 more that way. Okay, I should make it a circle rather than a square, but anyway, that would give you 100 times more ability to input if you were processing graphics through a smart glasses type of experience that allowed you through your peripheral vision. A lot of them today don't quite get out to your peripheral vision because of this narrow field of view problem, but I think that's where we're headed. So if you just do the math on that, we could give you information 2 million times faster by feeding you graphical in-context information through your peripheral and focused vision than we can by putting text in an app on an iPhone. And that's a big, big idea if we really want to figure out how to make all the information available to us from the IoT more consumable and valuable. So that's the end of my talk. I wanted to close just with one last thing, which is we, PTC, are hosting a very big event here in Boston in, I think it's in May this year. Yeah, May 22nd, called LiveWorks. It's really about that yin-yang, all that stuff I talked about, heavy dose on IoT, analytics, AR, VR, lots of partners. I expect we'll have about 10,000 people, and I hope to see many of you there as partners, exhibiting your own ideas, attending, learning what's going on, and so forth. It'll be at the Boston Convention Center, and I invite you all to come. So thank you very much. Thank you.
So I'll just